Nobody talks about what they actually found down there. And I don't mean the ships. I don't mean the planes. I mean what scientists pulled out of the ocean floor in the last decade that completely changed how geologists think about the Atlantic. Because the Bermuda Triangle story everyone keeps telling, that's the boring version. The real version is what keeps climate researchers up at night. Let me back up. December 5th, 1945. 5 Navy bombers take off from a Florida airbase on what should have been the most routine mission of the year. Training run. Clear skies. Experienced pilots, they had done this exact route dozens of times before. 2 hours in, the lead pilot calls the base and says his compass is broken. Both compasses, actually. Then the radio starts cutting out. Then nothing. 5 planes, 14 men, gone. No wreckage, no oil slick, no bodies. Nothing washing up on shore days later. Just gone. They sent a rescue plane out. That disappeared too. 27 people in one evening. That story spread for decades. Journalists ran with it. Then mystery writers grabbed it. Then cable TV ran it every other week for 30 years. And by the time the internet got hold of it, the Bermuda Triangle had become this cultural shorthand for anything unexplainable. Aliens, portals, underwater civilizations, magnetic death rays from Atlantis. You've seen the documentaries. You know how it goes. But here's the thing nobody mentions. The actual researchers, the ones with equipment and peer-reviewed journals and real funding, they kept going back to that area. Not because they believed in portals, because the geology underneath it is genuinely unlike anything else in the Atlantic, and what they kept finding was stranger than the conspiracy theories. Slower, quieter, and significantly more terrifying. Start with the ocean floor itself. Most people picture the bottom of the ocean as flat, sandy, boring. What sits under the Bermuda Triangle is the opposite of that. You've got the Puerto Rico Trench cutting through the region at over 8,000 meters deep. That's deeper than Everest is tall. Around that, you have underwater mountain ranges, volcanic ridges, massive carbonate platforms riddled with caves and sinkholes. It's one of the most geologically complex seafloors on the planet. And buried inside those sediment layers, there are enormous deposits of something called methane hydrates. Stay with me here because this is where it gets serious. Methane hydrates are essentially frozen gas. Molecules of methane locked inside ice crystal structures. They form when conditions are just right. High pressure, low temperature, deep water. And they're stable as long as those conditions hold. But if the temperature rises, even slightly, or if there's a seismic event that drops the pressure, they start breaking down. The methane releases. It turns to gas, and it rushes toward the surface. Norwegian researchers were mapping seafloor craters in the Barents Sea in 2015. Some of those craters were 800 meters wide and 45 meters deep, the kind of holes that don't exist naturally unless something exploded out of the rock with enormous force. Those craters were left behind by methane blowouts, massive eruptions of gas from underneath the seafloor. And when those researchers looked at what conditions would cause something like that, they immediately started drawing comparisons to the Bermuda Triangle, because the seafloor there has the same hydrate deposits. Same geology, same potential for sudden, catastrophic gas release. Here's what a methane blowout does to a ship. When enough gas vents upward through the water column, the water itself becomes less dense. The surface above the blowout essentially stops being able to support weight. A ship sitting on water that's suddenly 40% gas bubbles doesn't float anymore. It just sinks, straight down, within seconds. No time to send a distress signal, no explosion, no massive wave. The ship is just gone, pulled under by a column of aerated water. And once the gas finishes venting, the surface looks completely normal again. Calm sea, no debris, no explanation. Sound familiar? Geologists are quick to point out that these events are rare. The last major hydrate destabilization in the Triangle region probably happened around 15,000 years ago when the Ice Age was ending and the ocean started warming. But the hydrates are still there. They haven't gone anywhere. And the ocean is warming again, faster this time, and for different reasons. That part comes back later. The second thing scientists figured out is what's happening in the sky above the triangle. The Gulf Stream passes directly through this region. It's one of the most powerful ocean currents on Earth, up to 80 kilometers wide in places, moving warm tropical water northward at nearly 9 kilometers per hour. That warm water creates a constant temperature contrast with the cooler air coming down from the North American continent. And that contrast does something to the atmosphere. It creates what meteorologists call microbursts, localized, violent downdraft systems that form with almost no warning and can generate wind speeds over 170 kilometers per hour at the surface. They hit the ocean like a fist coming down from above. The wave heights can spike to 15 meters in a matter of minutes. And then it's over. The sky clears. The sea calms down. And anyone who shows up 30 minutes later sees nothing unusual. In 2016, a meteorology team from a Colorado university was studying satellite imagery of cloud formations over the triangle and noticed something that shouldn't have been there. Hexagonal cloud patterns. geometric shapes in the atmosphere that don't appear naturally anywhere else in the Atlantic. When they modeled what was happening inside those formations, they found that the hexagonal boundaries were acting like walls that contained and amplified those downward air blasts, focusing the energy, making the microbursts worse. An aircraft that flies into one of those downdraft zones doesn't have time to recover. The plane drops altitude faster than the pilots can respond. It's not turbulence, it's not engine failure. The sky itself just stops holding the plane up for 30 seconds. That's enough. And again, by the time search and rescue arrives, the clouds have moved on. Everything looks fine. Disappearance with no cause, no trace. Third layer goes even deeper into the physics. The Bermuda Triangle is one of only a handful of places on Earth where magnetic north and true geographic north line up. That sounds technical, but the practical consequence is significant. Every compass correction sailors and pilots are trained to make doesn't apply there. If you're flying through the triangle and you're applying the same magnetic declination adjustment you've been using all week, your heading is wrong. You don't know it's wrong. Your instruments all look fine, but you're drifting. And depending on how long you're flying, that drift adds up to tens of kilometers. That alone explains a lot of the historical disappearances from the aviation era, when navigation was almost entirely compass-based. But there's another layer on top of that. In 2020, researchers published a paper connecting the triangle to something called the South Atlantic Magnetic Anomaly. That's a region of weakened magnetic field that slowly drifts westward across the planet. When the edge of that anomaly overlaps with the triangle, compasses get unreliable. Electronics on satellites experience interference at higher rates. The magnetic shielding against cosmic radiation gets thinner. It's not permanent, it shifts over time. But when it's there, it's genuinely affecting the instruments that people are relying on to know where they are. The fourth thing is the water itself, and specifically what the Gulf Stream hides. Oceanographers tracking the Gulf Stream in detail started noticing in recent years that it constantly spins off massive rotating eddies. Subsurface vortices ranging from 50 to 300 kilometers across that can persist for months and drift unpredictably through the Atlantic. On the surface, they're almost invisible. Underneath, the rotational forces are powerful enough to drag vessels off course without any indication that it's happening. In an era before GPS, a ship caught in one of those eddies might sail for days thinking they were on course, watching stars that confirmed their heading and end up hundreds of miles from where they thought they were, out of fuel, out of radio range, with the captain completely certain he knew exactly where he was. But the most dramatic discovery about the water came in 2017. Oceanographers modeled what happens when wave systems from multiple storm fronts collide in the Triangle region. Gulf Stream waves, open Atlantic swells, and reflected waves bouncing off the shallow banks of the Bahamas all converge in the same patch of water. Under the right conditions, those waves interact and stack into what researchers call rogue waves. Single walls of water that can reach 30 meters in height, appear with no warning, last for a few minutes, and then flatten out completely. Rogue waves aren't theoretical anymore. They've been recorded by instruments on North Sea oil platforms. Satellites have captured them on radar. They exist. And the geometry of the Bermuda Triangle makes it one of the most likely places on Earth for them to form frequently. A 30-meter wave hitting a ship from the side doesn't leave much behind. The ship rolls, floods, and sinks in under 3 minutes. No distress call, no debris field that persists. Just a calm ocean where a vessel used to be. Now the fifth discovery. This one is the one that climate scientists are still processing. In 2019, an international drilling program pulled sediment cores from the seafloor near Bermuda. Long, cylindrical samples of compressed ocean sediment that work like a timeline, each layer representing a different period of Earth's past. What they found inside those cores when they analyzed the geochemistry was evidence of massive methane release events during previous warming periods in Earth's history. The most significant one happened 56 million years ago, an event geologists call the Paleocene-Eocene thermal maximum. During that period, something destabilized the methane hydrates across large sections of the ocean floor. Billions of tons of methane entered the atmosphere. Global temperatures rose 5 to 8 degrees Celsius over a few thousand years. The warming released more hydrates, which released more methane, which caused more warming. A feedback loop. Ocean temperatures at depth spiked. Marine ecosystems collapsed. The recovery took tens of thousands of years, and the cores showed that the Bermuda Triangle region was one of the places where the release was concentrated. Here's why this matters right now. Those hydrates are still there. The same deposits, the same frozen methane sitting under the same seafloor. Ocean temperatures have been rising for over a century, and the heat is penetrating deeper every decade. Nobody can tell you with certainty when the deep water above those hydrate layers will reach a temperature that starts destabilizing them. The models disagree on timing, but the sediment record is clear that it has happened before, more than once. And the trigger conditions look uncomfortably similar to what's building right now. Scientists are not saying the triangle is about to blow. They're saying the cores from that seafloor gave them a window into a climate event they didn't fully understand before. And what those cores describe is a mechanism that is still active, still loaded, still sitting underneath a major shipping and aviation corridor that processes billions of dollars in trade every single year. There's one more piece to this, found in 2022. While mapping the seafloor around the Bahamian banks, researchers found an extensive network of underwater blue holes, vertical sinkholes carved into the limestone platform, some of them going hundreds of meters straight down. These holes are sealed from normal ocean circulation. The water at the bottom doesn't mix with the water above it. So whatever settles to the bottom stays there, perfectly preserved, undisturbed for thousands of years. Inside those sediment layers at the bottom of the blue holes is a record. A detailed, continuous record of every major hurricane, every tsunami event, every climate shift that hit that part of the Atlantic for the past 10,000 years. Paleoclimatologists have barely started reading it. But what they've pulled out so far is already rewriting the historical record of Atlantic storm activity. Events that no human civilization was around to document, preserved in layers of undisturbed mud at the bottom of underwater caves. The Bermuda Triangle turned out to be an archive. That's the thing nobody tells you. You grow up hearing about it as a graveyard, a mystery, a place where physics stops working and people vanish, and all of that framing is wrong. Not because nothing dangerous happens there. Clearly things happen there. Clearly ships and planes have been lost in ways that are genuinely hard to explain with whatever information was available at the time. But the reason scientists kept going back wasn't to investigate the disappearances. It was because the geology, the oceanography, the meteorology, and the sediment record in that one patch of Atlantic Ocean are unlike almost anywhere else on the planet. It's not a cursed location, it's a collision point. The Gulf Stream, the trade winds, the volcanic seafloor, the hydrate deposits, the magnetic anomaly, the carbonate platforms, and the limestone cave systems all converge in the same place. And that convergence produces conditions that can be individually explained but are incredibly dangerous in combination. What killed those 14 men in 1945 was probably simple. Navigation error, compounded by worsening weather, neither of which required supernatural explanation. But the reason the triangle captured the human imagination for 80 years is that it sits on top of something real, something that the instruments and satellites of 1945 couldn't see, something that took until 2019 and deep sea drilling equipment to finally start reading properly. And what that something is telling us about the future is worth paying attention to a lot more than any story about alien abductions. The ocean kept this record for millions of years, waiting for someone with the right equipment to read it. We're barely through the first chapter.